Good.
How's it going?
I didn't get to looking at all the whole messages. I'll probably do that when I multitask here. Then I'll send you a short summary. I've spoken with John. I'm looking here. But
Okay, we're about to get started. No, you can't hear it? Okay, we're about to get started. Okay, thank you everyone for coming to LSVR Montreal IETF 102. So Gunter is going to walk us through in a moment some introductory slides. Can everyone hear me, by the way? Yeah? Okay, great. Some introductory slides. We're going to review the agenda. Just before we do that, blue sheets have gone out and should be circling the bases now. And we're going to go over the agenda. If anyone has any challenges or wants to move things around, let us know. We've broken the sessions up to try to structure the conversation as best we can. And we're also going to have a review of the interim meeting we had in June, just so everyone here has an opportunity to at least get the highlights of that as well. So, Gunter? All right. Apparently, I'm going to keep speaking. So, I'd like to ask for a volunteer. We asked on the list. We didn't get any volunteer for a Jabber scribe and note taker. And then, so we have a Jabber scribe opportunity. Country, you want to pick somebody?
Anybody? You will get like free coffee outside. We can't really start without, any of these things. So anybody? Doesn't take a lot of time, energy.
Okay, so I'll take Jabber scribe from up here. So now we just need a note taker.
Again, any volunteers for note takers? Your laptop screens look very interesting right now. Anybody? Come on, guys. I have a free Diet Coke.
There is the Etherpad. More than one person can help.
Yes, so there is Etherpad indeed. Somebody? Nobody? No, can we actually do like a working group meeting without note takers? I don't think we can. Yeah, so are like people willing to do like Etherpad? Nobody. So everybody's here and not willing to work. Perfect. Yeah. Okay. So I also, go into the Etherpad, and try to, make some notes. Okay, thanks.
Okay, so note well. We're going to review that in a moment. We talked about blue sheets, and then we're going to go to the agenda. There's a note well. Anybody who would like to speak should please review the note well if they're not familiar with the note well. So as mentioned earlier, we're just doing a quick intro. We will have a gentleman over Meet Echo help us with a review of the interim meeting we had back in June. Made some good progress, as well as a couple of key actions coming out of that particular interim meeting. We're going to maintain interim meetings throughout the next year or so, given the current momentum we need to maintain for LSVR. And then we're going to talk about the actual Bgp Spf draft, which is now adopted. It's an adopted document within the working group. We do have an adopted applicability document. Unfortunately, the adoption happened after the cutoff, so the new version will come in at this point now that the cutoff period is over. Then we will have a focused discussion around some of the requirements of neighbor discovery and liveness, and we'll, as we review the interim meeting outcomes and actions, we'll kind of dive into why that was an action and how we structure that within the meeting. And then we'll have a closing with making sure we capture any actions out of this meeting and what we would likely take into our next interim meeting. So before I proceed, is there any questions or comments on the agenda?
Hi, Alvaro Rotana. Just have a quick question. The agenda on the data tracker is different than that one. Is this the up to date, or is the one just one minor difference? But
okay, we should get it fixed up. The one on the agenda is the one on the data tracker is the correct agenda. So then we probably have a nit here, and we'll get that fixed up. We're going by the one on the actual data tracker. So you have the wrong slides. We may have a slide mismatch. So that's probably where the issue is. All right, so we should go off to Jacob at this point. Yeah. Okay. So we're going to pass the ball over to Jacob to cover a quick review of the interim meeting. So Jacob, you should have audio. You want to quickly test that? I don't see the audio. Sorry, give us 1 minute. We're trying to sort out the audio. Right.
Is that better? Can you hear me?
Yes, we can hear you now.
All right. I apologize for that. While in the virtual queue, I can't see the presentation screen. So I think we'll, maybe I can go back over here. Can you still hear me?
Yes, we can hear you.
Okay, fantastic. So the interim meeting was held on June 8th at 14:30 GMT time, or as what we call on the Pacific Coast over here, early. and it was about 90 minutes long and 10 attendees and the two lovely chairs sitting before you. So to kind of give you a idea of where that sits in terms of the overall structure of timeline, Interim Meeting 1 was between IETF 101 and 102, and then there'll be two other ones scheduled between each of the IETF meetings. So one well before November, to make sure things, as Victor said, keep on track for our aggressive timeline here. Next slide, please. So the intent of the meeting was to drive the deliverables forward, obviously, make sure we stay on track and things get done in a timely manner. When the start was just the current status of where we are now and what we intended to accomplish during the interim meeting. As far as actual content goes, Kior gave an update on the BGP-based SPF draft, the updates that had been made due to the comments on the working group. And I'll talk a little bit, there's a little bit more detail in the next slide. And then AC went through the applicability draft. And then we kind of established our next steps. So Kior's update on the BGP SPF draft, as it was submitted, most of the comments were included in the draft. He covered a lot of the changes made, and then there was some Q&A afterwards, one of which included whether other transports should be thought of as part of underneath LSVR. We've talked mostly, obviously, about BGP, but how do we structure that in terms of the overall working group? We had some discussion there. And of course, as a practical matter, said BGP is the obvious choice here. So there was some minor changes made there, and then we talked about an issue that Gunter brought up was what if there's different link state databases on the nodes, and we had some discussion about that as well. Next slide, please. After that, AC went through the applicability document. He went through each of these items. I'm not going to cover each of those again. You have, they were all incorporated into the applicability document. And so, as you'll see, we adopted that. So detail on any one of those can be found in the applicability document itself. Go ahead, next slide. So the next steps were, one, were we in a position where we can actually go through the adoption process on the applicability document? And since that time, since the interim meeting, obviously, the working group list put out the adoption call from the 22nd of June to July 6th. That was adopted. And then throughout the discussion in the interim meeting, the liveliness and neighbor discovery poked its head, something that we're going to talk quite a bit about today, later today. But we had a discussion about what we need is a common understanding of requirements, and obviously that's part of what we're going to be discussing today in just a few minutes. Another question at the end of the meeting was if there are any prototypes being developed for LSVR, please bring it to the working group list. And so that continues to be something that ought to be done as well. And that was interim meeting 1.
Okay, thank you, Jacob.
Absolutely.
So before we move on, is there any questions? I know it was a quick overview. We just thought we'd have that summary for those here who may not have had the opportunity to be there and or read the notes that are posted. So just 2 quick comments. So we took there's 3 key action items, as you can see here. The adoption of the applicability document has now been completed. That was done on the list. As noted earlier, we were just waiting for the cutoff period to end to get that updated and accepted in the system. And obviously, action item 2 is a part of today's agenda, and action item 3 was deferred currently while we work on the first 2 actions. So we are now moving on to the next part of our agenda, unless there's any questions before I move forward. Okay, Kier? Sorry, Kate, Kier. Okay, you look different.
So the status of the draft is that the base applicability draft just recently became a working group document. Many thanks to working group members for the feedback that they gave us. This base draft went through 2 versions of changes. Version 1 was presented at the event. I'm going to talk about that today. And then the version 2 changes were recently made, and I'm going to talk about that as well. Here is the summary. Here's the summary of the version 1 changes. We added sections to explain interactions with other Bgp Safis, peering modes are discussed, and liveness support. We've added a section on byte-connected graph heuristics. BCI applicability is now also covered. Any non-flow applicability is also been now discussed. And finally, the security section is pending, but we plan to cover it. Since it comes through, we will talk about that as well. So from interaction, from the standpoint of interaction with other Bgp Safis, the application draft now makes it absolutely clear that this Safi should be used for all practical purposes as an Untitled Safi, which means all the other Safis can use this Safi to replace the next hop information to create and resolve the next hop on this. It's also intended for flash network. This is primarily to be used in an environment where there are no entities and it's only Bgp-based traffic. Should IPv4, IPv6 Safi be enabled along with this Safi, then they should be treated just completely separate, is what the draft recommends. If it comes down to a point where the routes are added to the red from both these Safis, then the draft recommends that this Safi route should be given higher preference by default. Again, the config knobs implementation should provide config knobs to override that as and when it's needed. And the draft also suggests avoiding setting up any redistribution between these two Safis unless and until it's absolutely needed. Finally, the draft also talks about the interaction with LS Safi, which says basically that there is no correlation with LS Safi and Spf Safi. The only correlation is that the packet formats that were defined in LS Safi are inherited in Spf Safi, which also means any new extensions that will be defined in LS Safi will seamlessly also be applied towards Spf Safi. So those were the version 2 changes for Bgp Safi. More specifically, here is an example of a Bgp-based data center network. This network could be for private data centers or a public data center. If it's a public data center, the workload that would be on the server would be more like a VPN workload. Otherwise, it will be a private workload specifically for that data center. Typically, that edge between server and the list layer is LP. You could use LP or you could use VPNs as well. Everything north of the leaf layer to the spine layer runs BGP hop by hop peering. And if you have controllers, they could either coexist inline on the spine or could be off the network to some node anywhere within the network. So the controllers could be placed anywhere depending on what the operator is like and be set up. It could also have a full mesh peering with all the pieces also. That's a network dependent.
Kier, just, sorry. They're going to double check the mic. Apparently on Meet Echo, the audio is quite low. Does everyone in the audience hear the speaker? Okay, so it's just a Meet Echo thing then.
How about now?
Big difference.
So the peering could be sparse or dense. Sparse meaning the leaves in this topology could only peer with subset of spines. Dense meaning the leaves could peer with all the spines. The peering would typically dictate the path redundancy that an operator would want in the network. And it's directly proportional to that. Again, in such sparse BGP peering or a dense BGP peering, the liveness detection would be done outside BGP solely through BFD, which is defined for that purpose, right? The spines could act as a route reflectors, or it could simply do eBGP peering, right? And as I said, the controllers could coexist on the spines if needed, or it could be out of band if needed also well. Here is the topology that talks about exactly what I just said. You could have controllers either in band or out of band. In sparse topology, notice how the leaves are not, in this example, connected to all the spines, but subset of spines. So, typically in such networks, it's quite possible that every layer would have a southbound connection, which it passively listens on and establishes connections by default. And on the northbound, it has an ability to choose what the fan out looks like. Again, like I said, that fan out is directly proportional to the path diversity that an operator would otherwise want out of the claw networks. Here is an example where it talks about the sparse session setups. Notice how leaves are not connected to all 4 spines, but they're only connected to the subset of spines. Finally, the text is also added for DCI and non-data center applicability, right? Unless the DCI is collapsed into a collapsed spine, the SPF extension is only designed, or rather designed to operate on a fabric. So unless the DCI is a collapsed backbone, generally this extension would not apply to DCI and beyond DCI connections between data centers. You use some kind of an overlay for that. The draft also talks about the fact about the non-data center applicability, while it may have and be applicable for use cases that are beyond data centers, it is targeted initially for the data center-based networks. From a security standpoint, the extensions defined are built on top of BGP. So the applicability draft makes it clear that almost all of the security extensions defined in BGP would be applicable here, which means more specifically, the TTL-based security that's defined would be directly applicable here. Any session level security that's been defined, whether it's AO or MD5, would be applicable here. There is an RFC now that supports key rollovers using Yang-based model, which is 8177, that would be applicable here. So it's unclear whether BGP sec would be applicable here or not, but for now, the draft doesn't, or draft probably as when we add the security sections, would exclude that from the security solutions. So those were the version 1 changes. In version 2, we added a section that talks about peer discovery requirements. Specifically, we laid out high-level discovery parameters that would be needed for any kind of peer discovery that you would do. And we made sure that while the discovery specifically targets the data center networks, it doesn't limit the solution to such networks, because there could be a potential applicability at PEC boundaries on L3 VPNs also, and eVPNs if they use BGP. From the discovery mechanisms, there are few solutions that are out there. There's a solution based on LLDP, which tries to make the discovery more generic in a manner that BGP would be one of the discovery protocol, or the discovery information that is passed in LLDP would be specific to BGP, as well as it is made in a way that it could be extensible for other protocols. There's also a BGP peer discovery draft, which aims to augment BGP to do discovery itself. And finally, there's a new proposal that Randy is going to talk about today, which is link state over Ethernet. Again, a generic discovery-based mechanism, kind of like how we did BFD for all the routing protocols. So you want to think of LSOE very similar to what BFD does for the heartbeat. The applicability draft talks about at least picking one of the solutions, because we would need this for the data center networks. Whether the work's done over here or in IDR is up for the debate, but at least the applicability draft covers it. So at this point, the draft is in a pretty well shaped. What we need as a working group is to discuss, do we need to include any kind of routing policies, aggregation policies? If any of this needs to be included, then what sort of policies and what kind of discussion should we be having? Do we need to partition and talk about any Spf domains in such so that we could scale the solution as the DC networks grow? These are the two main topics that are out for debate, and we can cover them once we have some consensus, or we can keep them out. So that's all I have.
Okay, so I guess, is there any questions here regarding the applicability document or around anything he's reviewed?
Jeff Tansura, if you could review current young policy model. We've been working routing and see how it helps, applies what's been missing, would be great.
Absolutely.
Thank you.
And we probably should cover that out here as well, for sure. Good point. Thank you.
Care, this is to respond to question about routing policy.
Oh, I thought you were going to talk about peering, discovery mechanism.
I'm going to listen to Randy first before I have any other comments. Is Randy presenting that third option today?
It depends if Randy wants to talk about that.
Okay. I mean, I've read the draft, but I didn't know if it was being presented here. I thought that's what you said. We'll leave that till later.
I believe he's pretending as if he doesn't want to be part of this discussion.
My comment was on the other one. So while he's coming, let me just say
Yes.
it would be really good, being as I've got all this policy stuff floating in into the IDR working group, floating in from spring, to see what's coming in from LSR. If you want to do policy, if you don't, that actually gives some real viewpoint. It just would help us balance, the segment routing people have these wild and crazy ideas about policy that they think is really important. I'd like to hear if this is also important here.
So, this working group is all about being very sane, as you know. And one way we could cover this is we could say that, specifically in the applicability draft is that any policies that are defined inside BGP as an IDR or as a Spring working group would be applicable here, and we could cover them under a wider umbrella.
Okay, that's one way to do it. More meat on the bones is always good.
Yeah.
In trying to look at the requirements and then look at the resulting spec, I find I've got a sort of mono view coming out of Spring. That's good. They have a projected goal and desire. And by well and crazy, I just meant lots of functionality.
Sure.
if you have a different desire, it helps. That helps us as we review these things as far as a general BGP mechanism to be sane and to provide you good input. That was not to be pejorative toward anyone. It was just simply to say, please help.
Yeah.
And
And from the draft point of view, the only thing I would say is if you have specific text to cover that, we're happy to take over.
this isn't a space I'm working. Not a space I'm working in, not qualified lead operators, not me.
All right.
Okay, I can tell you what I want, just not what it is.
Super.
Did you want? Oh, well,
Sir,
oh, wait.
the SRT policy has nothing to do with routing policy. It's very unfortunate choice of words, I would say. Routing policy is what we do when we govern routing. SRT policy is a tunnel, right? So please don't mix them. They have nothing to do with each other.
Okay, correction.
Thank you.
I could clarify, but I don't know if I should go through the risk of clarifying.
We actually have a section at the end, you know.
Yeah, the one that shows made me AC, which I always wanted to be. So I'm AC.
Okay.
Thank you.
Okay, thank you very much. AC?
So I am AC Lindam, not K.R. Patel, except no substitutes. So I'm going to talk about the, we switched it up. I don't know if you've noticed where I'm going to talk about the base protocol modifications, which K.R. had been talking about before, and he talked about the applicability to try and get a fresh perspective on this. Oh, thanks. So the draft was updated end of May. We haven't had any updates since then. We have some probably that are pending. And what the perspective I looked at it is, what more is needed in the draft to make it complete for the original base spec? We don't want to go forward with things like trying to add segment routing and talk how you do that in Bgp Spf, because really it's going to mirror a lot of the work that's been done in the IGPs. But this is the main focus now. What more do we want? After we're done with this, we're interested in two things. That's network operator deployment interest and implementations. So one thing I noticed when I talked to some people that are BGP people about SPFs, they have an idea about it, but they don't really know exactly what an SPF is. And so I'm wondering if I shouldn't put a non-normative section like an appendix that talks about how you might want to do this. I'm just going to go this quickly, and it's good to go through this in the context of thinking about how you do this. So the first thing you do is you have a local rib, not the BRIB, a local rib, and you mark routes corresponding to the SPF state as stale. Then you start with your own router node NRLI. I hope everybody in here is familiar with BGP LS RFC 7752. You start with that at the root, and you'd add your local resources to the local rib, which is mainly just marking, we'll be marking the stale as active routes of the metric. And you optionally, I say optionally because in most CLO networks, you don't really want the prefixes that are all the links. You install those as well. Now, what you do for the links though is you add, this is a real simple SPF right now compared to all the variations we have in the IGPs, because it's only point-to-point connections between peers. So you add all those to your candidate list, and you add them in order, sorted by the lowest metric. And as you know, there's been discussions of using different metrics and different algorithms in IGPs. At some point, should this be successful and we deploy this, you could use those as well. Now, like the IGPs, and this helps make sure you don't install routes that are invalid, or even that you require the bidirectional check. In other words, you'd only put a node on the candidate list if and only if that node also advertises a link back to the node you're looking at. So don't worry, this isn't going to last too long. I'm just going to go through it at a high level. Then you remove from the candidate list the lowest cost node. You process local prefixes on that node, install those into the local reb, or mark the routes that were previously stale as active, and you're maintaining ECMP as you go. And again, optionally install routes relating to links for the node NRLI you just took off the candidate list, and you update those routes as well. I think I have some redundancy there. I probably could take that out. Then for that node too, you do what you just did for the root node. For that node, you look at the links, and you add those nodes to the candidate list, again using in the order of the lowest cost metric. Now, a lot of people use a tree for this, sorted by the metric. A lot of people use a heap, because a heap has a property of being a little bit less overhead, but you still have the lowest cost. You can have the lowest or highest for it, depending on how you do the heap on top. And then you go again with that. You process the links, and you honor the bidirectional connectivity check for the nodes that are more one hop away, just the same as you did for yourself for the root node. And you add the nodes from that node that are connected links to that node to the candidate list, again in the order of the lowest cost metric. And then you repeat starting at the top. Then when you're all done, this is like a very single area, very simple single area SPF and ISISRO SPF. Then you look at your local RIV and you determine the changes, because of course you don't want to hit the ribs and fibs with anything that's unnecessary. So you delete, add, or update routes based on that computation. I was thinking maybe just as a reference, I could put something like this in an appendix. You had a mistake, a bug?
No, I don't have a bug. You have a bug. Alvaro Retana, routing ID. I think you must put this in the document. You're defining a new protocol. You need to tell people how to run SPF. I mean, it is different than
it is. That's what when I was talking to people, I mean, to people that had thought about it, it was intuitive, and I talked to people and they completely didn't know. So I think you're probably right.
Right, because we want to make sure that not only that people don't assume things, as you already said, but also that we can have interoperable implementations. If I assume some things about SPF and you assume some different things, maybe we might not end up with a consistent view of the table everywhere. So yes, putting something in there is important. I was just looking at the RC, the draft really quick, and it says something like this draft defines the SPF algorithm similar to OSPF. So, yeah, I mean, it doesn't actually define that in the first place. And second, similar can be interpreted in many different ways, right?
Exactly, and it is different because you have a different granularity. OSPF and ISIS have different granularity. This has a third different granularity of the way the link state is advertised and processed.
So even much more important to describe exactly what to do.
I think it is too. Yes, I think so. I don't know. Jeffrey.
Given your experience, perhaps you could describe how to cache policies as you walk down. You've done this before a number of times, So optimization of policies with SPF. It's not normative, but you know how to do it properly. Probably.
Okay, yeah. Let's take this offline because I think this could get into some real details. Exactly, what you're talking. Thanks. Okay, here. one thing that caused a lot of confusion was the base SPF versus the strict SPF. Now we're reusing an IGP registry for IANA. And in this context, at least for the initial version of this, the strict, even though we're reusing that registry, the strict SPF isn't really applicable, because right now strict SPF is only applied to SR, the segment routing computation, in documents that are close to standardization. So we want, since we're defining these TLVs, we know we're going to need an algorithm at some point if we're successful. But for right now, this is, I think I'm going to put in the document that the base SPF is the only thing that's described and is applicable. Okay. Kayer talked about this a little bit in the applicability document. I thought about what you would do with policies. Now, right now, a lot we thought, do we need areas? Of course, since it's BGP LS for link state, of course, the 7752 encodings already have area IDs, and you could just reuse that. But we're thinking right now, our current thinking is we don't need areas. We're not going to put any areas in the first step. We're just going to leave it. It could easily be added later if you need it, and you just take what you have and say that's area, that's area 0, or you have to redefine it. But one thing we're not precluding is that if one of the nice things about BGP as opposed to ISIS and OSPF is that if somebody is so inclined and they know what they're doing, it's a rope and a chair, you can define policy at any level. And we think people should, at least I would recommend that people do provide policies for BGP-LS in their implementations that you can inhibit NRI from going, being advertised on specific links or neighbors or whatever, and also that you can aggregate prefixes from your local rib and advertise them as NRLI that is originated by your source, by yourself, much the same way as an OSPF area border router would do. So that way you could, if somebody was willing to go through the thinking about it and the configuration, they could define an area boundary any place they wanted, or a quasi area boundary any place they wanted, and do the policy themselves. And again, I just have a warning, since it's not automatic, it could break things. Of course, you can break things with OSPF by misconfiguring areas as well. SPF domains. This is something I'm saying we do have a concept of areas. Do not have it here, but maybe we want to do domains. This is a big question, because what a domain would be is if you have two separate, complete, like I would say this would be more analogous to some people that have been so compelled that they needed to use multiple instances of OSPF or ISIS in the same berth, and or in the same. And what you would do here is you could have an instance identifier, and somebody on the boundary could, such as an ASBR, could use these and provide policies to redistribute between them. Now, do we need this?
So, Kayer Patel, speaking as a co-author, I think it's really cool to cover this, because then you could break a given DC into a bunch of pods, and you can assign domains per pods and do a much more restrictive route distribution across the pods if needed. So it gives you a good control aside from the scale, yes, if you will.
Yes. Jeff, as a significant motivator for BGP-LS period was the fact that doing things that span IGP domains was painful, and it provided a way to actually gather things in one spot. There is a little bit more speculative work about actually taking multiple separate domains, that are completely, not even just areas or levels, just simply gluing together more than one with taking the different views and applying the glue in the middle through, MPLS or something like that. So rather than take this as a, should we think about doing this, take it as a given.
Okay. I think that's good because once you specify something precisely, you're going to have people disagree with it and you're going to shake out a lot of things too, rather than leaving this to say, well, we have policy in BGP, you can do this anyway. But yeah, I think we'll have something explicit for domains in the next revision.
Yeah, maybe one thing to add about domains itself is that, if you look in the charter, we're not really chartered to actually, have the work documented for multiple domains, which doesn't mean, that we should, I think the solution we develop should not exclude the potential for domains, but the actual, the embodiment of that is maybe a little bit too far, from what we actually, are chartered to do at this point in time.
Okay, that was Gunter.
This is Alvaro. Yeah, the charter actually says a single distribution domain. And I think what we meant by that was more the concept of a flooding domain or an area, right? And the charter also says that, I can't see the charter from here, but it says that a single distribution domain is defined as an administrative domain. Now, we can bend this any way we want, right? Claiming that you can divide your data center into multiple administrative domains, and so you end up with this, right? In the end, if there is consensus to do this, we can figure out the charter later. One thing that I've told the chairs several times and other people is I really want the working group to focus and not to add stuff and add stuff and add stuff just because it's cool to do it. Mm-hmm. But, as Jeff said, there are some things that maybe we want to consider from the beginning. So don't let the charter, stand in the way of putting an identifier for a domain, for example. Okay. Maybe not go crazy with areas and everything else. Right. Maybe that's next year when we recharter and do other stuff. But yeah, I think that the way we wrote the charter, it's bendable enough that we can get away with things and not have problems with it.
Thank you. Yeah, let's write something about that and see how complex and how many holes it has in it. And maybe if we can think of something simple enough that has that is a pretty ironclad, we'll keep it in. Been good? Okay, this is one thing that the decision process. One of the there are really two things that we changed significantly in BGP. One was the computation of routes, how it's done, whereas distance vector versus SPF, and the other one was the determining the best path. And I have this in there. So a BGP SPF, because the node ID is part of the NRLI key, it's inherently originated by a single router in the Bgp SPF domain. And the rules are, you always prefer NRLI from the originator of it, even irrespective of anything else. So if the BGP ID is one of the node identifiers for the NRLI, you're getting it from that guy, you're going to prefer that. This is to handle the case where you have a cold start and there's still stale. Now, I don't know how this would happen, but because by that time it should have converged and this should have been withdrawn from everything in the domain, but this would handle this case. Otherwise, we're using, I don't know how many of you are familiar with EVPN. In the Mac mobility, there's a sequence number. We're using a similar concept where the originator will put a sequence number on it. And you're always going to prefer the most recent or the one with the highest sequence number. We're using a 64-bit sequence number. That way, that was similar to what we did for the it's not called a sequence number. What do we call that in authentication where you have a counter to make sure that for replay attacks? Okay, yeah. So we're using 64 rather than 32-bit, and we're using a similar wrapping strategy for if a router restarts the high order 32-bit updates and 4 billion for a it'll handle both cases anyway. And then we don't think we need any further criteria. Now, here's where we get into something. The normal, the difference between BGP and IGPs is IGPs for things that are withdrawn. The IGP has an advantage because it's withdrawn. IGP only keeps one copy of it, whereas we'll keep a copy from everybody. So unless you do something, one consequence of this is you won't converge on the deletions as fast unless we do something else. So do we want to modify it or just do the normal BGP and wait till all instances of the most recent? I've been thinking about this ever since Jeff said, what about the case of node failure? And the first time we talked about this, and he's at the mic right now.
So Jeff has, you're absolutely correct. I will face Randy so he can see me. Doing this type of procedure where we have basically identical NLRI, we're just keeping track of where they're at, can be done internally as a special optimization for things that you might actually know have this property. This is not normal for BGP. Normally BGP wants to keep n copies of things, and there are relatively few circumstances in normal BGP routing where you would actually do this sort of thing. So whether you choose to say that this might be a possible optimization or not, I would not recommend changing the BGP procedures, but making note that this property should exist is worth doing. Where I think you may run into trouble is thus far you haven't gotten into route decoration yet. At what point may nodes start doing things like adding communities, adding on additional path attributes locally or distributed route reflectors that would break this property.
Keyur Patel as Arcus. I think it's going to be hard in the hop-by-hop networks with the packet format like BGP to figure out if the node failure is the root node failure versus an intermediate node failure. I think covering this inside protocol, I agree with Jeff that we probably should keep it out, but have implementation specific extensions that they could do to figure out where the failure is and how do you adapt to it and how do you sort of take one update that you received and extrapolate information and sort of correlate it to the other updates and do whatever is needed. Those are implementation specific details. We could leave it out.
And I'm not going to use any of the backup slides, so I'm done. The backup slides were only the changes. I had them for people that didn't go to the interim. They can look at them and see what changed in the versions. Yeah.
Any other questions or suggestions? So something what we're planning to do is to create like another interim in about a month and a half, 2 months from now, mainly to drive the documents further. Now, what I will also request on the working group email alias actually is for the volunteers to actually review the documents, because even though we believe that the current state is reasonable, it can always be improved in such a way that we can actually add things, remove things, correct aspects itself. So I will, like I mentioned, I will actually ask this on the email alias also. But any volunteers to actually give the current 2 main drafts like a read already and commit to actually give feedback on those either on list or during the interim. You don't have to stand up right now, but you can.
It's not necessary to answer a question, and speaking as routing working group chair, we extensively use early reviews from routing directorate, usually before we adopt the draft and then sovereign process. So do the same. It really helps to fine-tune the document.
Okay, cool. I'll do that. So let's have a quick look at the correct agenda now that I've uploaded this thing. So we have like a couple of topics, remaining here. And so we are, at this point in time, we are at the, we're going to start the discussion or like, sharing of some ideas about like neighbor liveness requirements, because, distributing these link state vectors, we need to create them in some sort of a way, automatically. So that actually has some requirements and some, embodiment, associated with. So we're going to be talking about that. Then we're going to be, discussing, some of the potential options. Then we're going to be closing. Now, before going there and actually, asking, Randy to, start with his slide deck. So while we have like, majority of our milestone documents, covered, one of them, has seen at this point in time, like, it's very dormant. It was mentioned, a couple of minutes ago. So we actually have like in our charter also some young model specifications. Maybe it is still too early. I'm trying to understand, how to deal with that, going forward. Do we actually, think they should be in the applicability document, as part of it, or should it be part of like, a separate, independent document itself? Any ideas on thoughts on that? Because it was mentioned, a little bit earlier, how to deal with that best.
Keyur Patel, Arcus. My suggestion would be to at least enhance applicability document to say model should be covered, and then probably come up with a separate document that says here is what the model looks like for the solution that we may end up having.
Okay, works for me.
And just from the Jabber list, there's a yes, agree. So on that last comment. All right, so unless there's any more questions on that part of the agenda, we're moving into another part of the agenda that was one of the outcomes of some discovery and work we did during the last interim meeting, which was to at least understand what we would require from the specs perspective as to what we would need for liveness and neighbor discovery and or detection. So the thought pattern there was to work on what do we require first. So we know there's some obviously some options out there, but to have a discussion. So we've asked, we look for volunteer. We have one coming up to the mic now to at least help frame the discussion. So what we'd like to do is make some progress in the discussion to see if we can get some agreement as to what we would need. And then we will review a couple of drafts which have some potential applicability in this area. And then we'll see where we land at the end of the discussion as to some move forward options.
Okay, as opposed to the last discussions, I'm a minimalist, so fair warning. Okay. We're down at the data link layer trying to find our neighbors. Okay, and that's all we're trying to do. The rest of it, Bgp Spf can handle. That's the theory. I'm willing to argue that theory if somebody has other ideas. Okay, so I'm going to be a little religious for a moment, if you'll excuse me. And I greatly would appreciate any attribution. I don't remember, I can't find the quote, but it's either Tony Hoare in his Turing speech or Klaus Wirth. But there are two kinds of standards. Union standards, which is all the features everybody ever wanted, which I think we need to be very careful of in this group. And the intersection standards, only those things everybody absolutely had to have. Okay, I'm a fan of the latter. The good example was in dealing with the ITU, Ruff Housley said, so let me get this right. You just keep adding features until the no's stop. And they blushed and said, well, we don't like to think of it that way. Right? So what must we have? Okay, we need to discover the nodes and the links so that Bgp Spf can figure the topology. All the brains and the routing and the topology are upstairs. Okay? We need to discover link encapsulations. Hey, I have a neighbor. Can she talk IPv4 with me? Can she talk IPv6, MPLS 4 or 6? And then what addresses are on that interface, not what is behind it. Routing is upstairs in BGP. We want to maintain liveness. Okay? And we need, of course, the northbound API to Bgp Spf. Please feel free to come to the mic, throw vegetables, etc. This is supposed to be a discussion. Hey.
Hey.
Who are you,
go
Jeff?
Back. Jeff Tensor. Don't we need more generic solution, just northbound API to Bgp Spf? And this discussion is supposed to be auto discovery for data center routing. So why Bgp Spf specifically on the slide?
Because this is a auto discovery for LSVR. Now, only, and LSVR is centered on SPF. I can't help that. Now, just to switch hats, and let me be very clear, I am switching hats. I have another presentation later on some suggestions for this that
Understood.
I hope would be applicable more widely. But the question is very narrowly, what must we have here?
No, just confusion, because topic was supposed to cover what we really need in data center, not in LSVR, right? Or it could be me who's confused.
What I was assigned was,
Yes, Gunter van der Velde. So the idea was indeed to actually, have the requirements from an LSVR perspective. So the must-have here is correct.
Keyur Patel, Arcus. I think from my perspective, what would be nice is if we see requirements out here that actually can address LSVR needs, but more specifically be done in a manner that is very generic, so can be extended in future. Again, a good example, when I say this, we should think about is BFD. How BFD has an applicability to BGP and ISIS. Something similar out here. If we could do that, that would be fantastic.
yeah. Okay. Sorry, as you saw in the previous slides, I try to stay really, what's the minimum? We're all very good at adding features, and I just don't, I'm not a big fan of that. Oops, must-haves. Security, I have a real problem here. Oops, Sue.
Previous slide, I expected liveliness. Can you define that more precisely? Because there are different things of liveliness.
I'm not going to do a very good job of that.
Pardon?
But I think you could do a better job of that than I can. Is this link up? And then the criterion we continue to have is twofold. One is for what encapsulation, and B, how often. And
Are you looking, is this link up? How much encapsulation do you have? Are you requiring transport to go across it? That's
Miss Lewis.
transport. Because you're doing this via BGP, and BGP says you have to have a certain amount of transport capability.
Right.
And so is that what you mean by liveliness? Because I expected to hear that in one of these last two comments, and I didn't hear it. Took me a while for my brain to work.
Here comes the attack. Jeff hasn't spoken. You go first, Jeff.
Jeff Sue, I think the confusing point here is that this is not necessarily a component that is in BGP SPF. This may be a standalone protocol.
I think Sue got that.
I realize that, but the context in which you're talking about this is for BGP LSR, and you're asking for must-haves. And if it's in that context and you require TCP for this protocol to work, for this protocol, the must-haves must include, I believe, transport.
Well, yes and no.
That's the discussion I wanted to hear.
I agree with your need. In other words, since we're trying to keep BGP SPF alive, BGP SPF is going to have to work between these devices.
Yes.
I understand that. But does the discovery and basic liveness have to do that? Or can we say you run BFD or the equivalent after you've gotten the ability to run this? And you'll notice that when you get to my suggestion for this particular issue, I say, we're just trying to do the encapsulation liveness, and you're expected to run BFD on top once you've got that.
May I ask how this makes sense? Just so if you have these two liveness protocols when you're working for fast convergence, and I assume the reason you're going for an SPF inside of all this is you do have some concern for fast convergence, that if you put two protocols together, you're likely to be less fast than if you have one as far as saying hellos.
Keyur Patel, Arcus. I think, so if I were to clarify, and the way I read this is, these are simply a discussion points and a requirement, not a solution. Anything that calls a liveness in here is specifically in context of BGP or routing protocols is BFD, where we won't define any, or at least I don't see a need to define any other protocol extension to cover the liveness aspect. What is needed here is a discovery, which is what I believe what I heard Randy was alluding to, and the specific requirements for discovery. Should the protocol be designed over UDP or TCP, then you need some kind of a reliability in here, otherwise you don't.
I didn't see where we'll go. I'll go to the end of the line.
Bruno Reisman. I have two comments. I'll just give them both and then let you respond to them. One big decision point is whether we should support multi-point LANs or only point-to-point interfaces. That will make a big difference. And we could get away with just point-to-point in a data center if we want to minimize requirements. And the second comment is that you mentioned the must-have of discovering addresses on the remote side. I could see how that's necessary for V4 and V6, but we should be careful not to include discovering downstream labels. That would be for higher layer protocols.
Downstream labels?
Yes.
Or what about just the neighbor label?
We should have a discussion about whether that's in scope or not.
AC Lindum, I just like to, I think the maintain liveness, you know, a lot of people saw that a different way, and I want to say that I agree with what Randy said, that we shouldn't try and maintain the session once we bootstrap the encapsulation being there. We should just use BFT. I mean, there's so much interaction and machinery for BFT implementations. You don't want to do that again with any other protocol.
My inclination, I think it's based kind of on what Keyur said, is that my responsibility at this level is to tell SPF, your topology has changed. An encapsulation may have gone missing or come up, or may other topology affecting things have happened, not how reliable it is. It's alive, not, it doesn't have a fever and isn't puking. Sorry.
Yes, hi. Himanshu from Siena. Probably a naive question. LLDP always existed, has always been there, but none of the IGP protocol use them. Why use LLDP and not use what other IGP protocols use for neighbor discovery?
Let's go into that when we start looking at what the alternatives are, which is where we're heading, and will be the last slide, which is comparing all the alternatives we've seen out there, LLDP being one of them.
Okay. Karavdavra, LinkedIn. My only comment to this is that whichever way we go with liveness or discovery of labels, let's keep it simple from operations point of view. That's important.
Thank you.
So this is me asking the question in another way. I'll try to be more clear. Is your requirement to have two stacked protocols so that you can find out what the encapsulation and then put TCP on top? Or are you trying to bring up the liveness in the quickest way possible? I would have thought you would have tried to bring up the liveness in the quickest way possible. That's why I'm confused how two protocols can interact as quick as one.
John Scudder, I don't want to lead the witness, but considering that this is essentially a slide full of requirements, I think that maybe your question is there a missing bullet on here that has to do with timeliness?
Yes.
I will pretend to think about that for a while, but I won't bore you while I'm thinking. Is security requirement. To my great horror, data center operators seem not to think of security at this layer. They have walls around this thing. Everything's safe. Nobody comes in with laptops and USB sticks. Just ask the Iranian bomb workers. Do we want to add authentication and maybe integrity? Are those requirements? Okay. Watch out. This is one of those things which is likely to drive the size over 1,500, and 1,500's a magic thing. LLDP hits IPR at 1,500. Okay? So, in one of my hats, I'm a security person, but I don't want to shove that down this group's throats. So far, security has not been an issue here. Non-features, routing data. That's why the goddess invented Bgp Spf. We shouldn't be doing it at the discovery level. Access to IGP databases. This is discovery and liveness, not routing. Bgp LS does too much detection or translation of ISIS, OSPF, LSBs. I just, we're not trying to do routing.
AC Lindum, there's an interesting point here that I had in the LLDP draft, but I took it out, and I noticed now we have a fourth option. Robert invented one over the weekend, and one of the things it allowed for was you could learn a loopback and have that layer install a connected route to the loopback. So you could peer on loopbacks directly without going through anything else. Now, would we want this or not? Would we want to disqualify this right here and now? That would allow you to have complete unnumbered on all your inter-switch links in the data center.
I'm not a fan of unnumbered, but I still am a fan of loopbacks. Right? But yeah, but I don't think I have to have routing to do that. I just have to say, I have this address available and it has this attribute.
Okay. I guess that is a connected route in everybody's implementation. But if we could we could allow that then. You could say that this protocol could do that.
I am inclined that way. I don't know what the sense of the room is. But
K.
here's
Patel.
somebody supposedly sensible.
K. Patel, Arcus. I think that's an implementation, if you ask me, I think that's an implementation specific detail. If on an interface that you run, if on an interface, say you get a packet where you have a BGP peering address, which is different from the interface address, but a discovery is telling you to peer over that address, I think you could add a text that says that this address that you've received over this interface, while it doesn't belong to that subnet, will recurse over this interface. That is what at least the discovery protocol should cover, right? So if you were to do that, then the natural way to do that would be, or a way to do that would be to inject a route that says this route recurses over the interface address.
John.
John Scudder, I love how we're designing a solution during the requirements phase.
I know.
It does seem to me as though it would be, I know you're trying for minimal here, but it would be awfully good to have a way to bootstrap those loopbacks, because we're building an IGP out of BGP here, and otherwise you get this horrible stack of layering violations. So I kind of like adding that into the requirements, leaving aside the question of what the solution is.
I will put that explicitly in. And as you know, send me an email so I don't forget, please. So we want discovery and liveness for BGP Spf. We're trying to deal with networks of greater than 10,000 nodes. We're trying to deal with serious scale. We'd like it to be useful for other applications. We'd like it to be simple. We see immediate possible extensions, authentication, cost, etc. Oh, by the way, we want it simple. And I think we'd prefer no IPR. And I just ran out of room on the slide. I would also add I'd like it simple.
Prioritization of this dysphoria. Two thinking Randys in one meeting? I rock.
Simple comes first.
Okay. Then see my earlier comment on timeliness and one protocol.
It's to John's layer violation issue. So let me just jump up and down on simple one more time. I presume everybody can read, so I won't read it to you. But, you know, we are not telcos. We don't demonstrate macho by seeing how complex we can make things to provide barriers. We're trying to make it simple so it works, is understandable, and is securable. Okay, and Rob Pike said this just 2 weeks ago, so I had to stick it on there. Okay, and for those who don't know who Rob Pike is, you can skip it. Okay, who are the candidates that we have so far? I'm sorry, Robert came out too late for this one. So, LLDP, ISIS link discovery. Alvaro loves to find bricks as he's walking down the road and throw them over the fence. So he threw edge control protocol at me. I am still digesting it, Alvaro. BGP neighbor auto discovery, which will, I believe, is the next song. So you'll get that one. And the song after that is link state over ether. Okay. And some comments on each one. LLDP is an IEEE protocol. Watch out, it has IPR over 1,500 bytes. Okay, and we don't care about that for the simple stuff, but if we start trying to put security associations and other things, this could become an issue. It won't go through a switch. Is that a feature or a bug? I don't know. Right? If in the data center, those are switches. So who cares? It's supposed to be talking to me. But for talking extensible, it beacons. It's not really keep alives. It's viable, but sir.
Hi, I'm Paul Congdon, Tulloch Networks, also author of LLDP in 802.1. Your comment about not going through a switch is not entirely true. It depends on what address you put on the LLDP packet. So you can have it propagate various distances.
Thank you. ISIS discovery, IETF now has control. It's complex enough that BGP-LS was invented so normals could get to the LSDB. You're supposed to laugh. ISIS is not commonly implemented on many of the devices MSDCs see today. Right? This is unfortunate because I'm an ISIS bigot. But that's the breaks. Okay. Edge control protocol. Alvaro, did you really look into that before you threw the brick at me? It's a transport.
Since I'm, I want to attribute to point the right attribution.
Oh, passing the blame shifting.
So I'm really glad that Paul is here because when we talked about, or when we started talking about IPR and LLDP, what I did is I reached out to the IEEE and asked. And one of the answers that came back was, we don't know, but in any case, we probably don't want to extend LLDP beyond 1500 bytes, even if we could. And so Paul actually threw the brick at me. I just relayed the brick to you and said, how about ECP? So I don't know is my answer to your question. A better person to answer would be Paul. If you have
Am I kind of right here that it's a transport, really? It's a reliable layer 2 transport. And it has flow controls, ordering control, etc. And it's kind of, then it shifts into being, saying, hey, if you're having trouble at this layer, we shift to TCP.
AC Linda, one detriment to this protocol is that while just about every switch implements LLDP, including the option to send on not the DMAC, multicast. I'm not familiar with this one. I don't know if anybody implements this.
It's pretty new.
Yeah.
It's pretty new.
So if we're going to create something, if we're going to have to something new anyway, then
we'd rather our own new than their new.
Yeah.
I'm less biased. I was brought up in a liberal family.
Yeah, Paul Congdon again. Yeah, I think your assertions here are relatively correct. It is a transport. It was intended to carry more than one MPU or PDU's worth of data in a reliable fashion, and primarily invented for the EVP, for the Edge Virtual Bridging Protocol. There's some recent proposal to use this for some new 802 discovery, or not discovery, but state exchange protocols that require large data transfers. Taking my IEEE hat up, I'm personally not in favor of using it for those things. It's adding a lot of complication to some other protocols as well. TCP works just great. So
yeah, but when your AD says look at it, you got to look at it, man. Okay. There's the BGP Neighbor Auto Discovery draft. It is an IETF protocol. It's very new. It kind of confuses me as to whether it actually does discovery or not. It seems more it's configuration. Okay. It's AS based, does not use other identifiers, and it's not really, it's more configuration than discovery, and it doesn't do liveness. Okay. Robert's new thing, I'm sorry it's not here. My quick take on it is that it's discovery at a top level, not liveness, and AS based. Link state over ether was custom designed for this particular job, but conflict notice, I'm a co-author of this. And it's very bare bones, brutally simple. Does discovery and liveness. It's new. So is Bgp Spf. The bottom statement is true of too many of the items on this laundry list that I've presented, which is measurement and monitoring is vary among these. And as an operator, Sue.
This is a question about a protocol not on the list. There's a basically ESIS protocol, ancient, but did you consider that particular one?
No.
It might be worth considering. I can detail the reasons after why.
Pardon?
I follow the great example of Tony Lee, who crypted it for many of his other things. Thank you.
And then this is the final slide, just trying to sum it up. And of course, when summing it up in PowerPoint, you lose too much information. And now we're supposed to have discussion. I'm very happy that we had some during, but this allows me to escape the mic.
Okay. Thank you, Randy. Any, again, this was the initial discussion. We are going to talk about 2 related drafts now. Are there any other comments? I know we had a lot throughout the discussion. Was there any other things that anyone wanted to bring up specifically? Any strong disagreements with anything that we've discussed so far? Or is this a fair summation? Okay, so.
Yeah. So from what I understand is that, most of the aspects, sorry. I think from what I understand is, there is like no, violent disagreement on what Randy actually, mentioned here. I think one of the key topics we probably, which needs to be, further considered is the timeliness aspect, which was mentioned. I think for the rest, from at least from my perspective, majority was, we were like in agreement on this set of requirements. Correct?
John Scudder, not to disagree about any of this, but I will note that, Randy had a big question mark around security. And I think, you don't have to answer it now, but the group does need to answer it. I said, there's no proposal on the table right now regarding security. You just said, here it is, it's not addressed, pretty much. And or is there a sort of, I guess you actually had a straw man on the table which said security is not a requirement beyond, these, 4 strong walls built out of cinder blocks. Which is the correct summary, I guess, of?
I think the summary of what I said is the latter.
Okay, then I guess I do want to disagree.
My personal desire would be, must at least be extensible to be able to handle security associations. Okay. I am most particularly interested in the authenticity of my neighbor.
I could get behind that, but these guys were asking for a sort of disagreement with the requirements as laid out.
I appreciate your pushing on that one. I didn't feel it was fair for me to.
Right.
Because I'm a security person and I don't feel much support out there in the data center space. I think they're bloody insane. But
there you go, plus one. That's my comment.
They're the customer.
Jeff Haas, this is mostly for the rest of the room. We've had this conversation wearing my BFD chair hat. We've talked about BFD as being possibly used for the liveness piece of this mechanism. The mode that BFD gets run in can impact whether it's really suitable or not. The specific example is standard point-to-point BFD, stock 5880, expects to have a single session between two IP endpoints. And typically an implementation will try to get the most aggressive timers it can if you're having two applications wanting to use BFD for the same set of addresses. And normally that's what you want to do because you want the faster thing to fail and take everything else with it. Somewhat in contrast, think about BGP. BGP probably can live with, like, say, 300 millisecond keep alives happening as a liveness mechanism. Maybe a little bit shorter if you're looking at doing this for BGP Spf purposes. But if you end up tying single session that's doing liveness and also link liveness, liveness of your protocol and link liveness together, you'll have the faster session negotiated. It'll go down and potentially take the protocol fate with it, and you may not intend that. So if BFD is the thing you're looking to use, there may be work to be done in BFD, or at the very least, figure out how you want to use BFD with the existing constraints.
Rob Ostine, Arcus. In spite of being known around here more as a security person, I'm actually not here to talk about that, although I agree with Randy that it's nuts not to have something. But to Sue's comment about one protocol versus two for faster convergence and all that, I don't think of it quite that way. It's been a long time since anybody was dumb enough to let me actually write routing code, but my recollection is that the hello phase in OSPF is basically a whole separate sub-protocol. It's just tightly integrated with the rest of OSPF. And I think what we're talking about here is essentially equivalent to the hello phase. It's basically just link discovery. So whether that's actually a separate protocol or just an add-on to the side of BGP for this purpose is mostly a matter of semantics, I think.
I'm an ex-compiler, I have semantics.
So Rob, I'm sorry, Randy, I will disagree with your analysis. And if you would like to see charts afterwards, we can diagram how some of this stuff works. But I really think that, and it's personal opinion, that you should, see people, you should consider timeliness, how the code works, how everything works. I think the timeliness is important, or at least it's a question to make a decision on. It's off the list. Just, you were asking if I thought the list was complete. I'm asking that you do a reasoned discussion on timeliness. If you decide out, I'm still going to support and work with stuff. I just think you ought to think about it.
Alvaro Rotana, I just want to go back real quick to the security point. I understand the challenges of deploying security. I understand the challenges of deploying security and how people don't necessarily want to do that. I think thinking about moving whatever solution forward at some point, we will want to think very well about how we justify that. If authentication, integrity, et cetera, is not baked into it from the beginning, but it's an extensible option, that may be okay, but we just want to be able to justify that so that others in the ASG, for example, will understand where it's going to be used, why we're doing it this way, what are the normal modes of operation. We've done other protocols. For example, in Manet, we did a protocol called DLAP, which runs inside a tank, inside a copper cable in a point-to-point wired network. And we had a discussion with security people about why don't we have integrity and encryption and everything else. And the answer was, well, if you can actually see this stuff in this protocol, you already broke into the tank, right? And you have bigger problems than that. So we got away with explaining what the normal use is, while at the same time saying, but if you don't use it here, then here's the extensions to go do all this other stuff. So I'm happy with, or I'm okay with not putting too much overhead into a protocol like this, We just need to be able to justify that so that it's clear to everyone what the motivation is and what the operational circumstances are around this.
Yeah, once they can get on the wire inside my close, then I'm already dead. That's one theory, but I'd like to, just for giggles, are there actual data center operators in this room? Could you raise your hands? Okay, those people who raise their hands, do you have security concerns? One more just walked in. Actual data center operators. How seriously should we take security at the discovery level? In other words, authentication of your neighbor. Gaurav.
Gaurav Davra, LinkedIn. Very serious.
Do the other paltry two support that?
I'm going to go and come and talk a little bit more. Daniel,
Could you
Canada.
eat the microphone, please?
Daniel Woyebel, Canada. Before I answer your question, and the previous speaker, just before you, has an interesting question in his update status, which was network operator interest. I think we should pull a little bit more the operator when you propose something like you were proposing, so we could be aligned a little bit more. From a security perspective, it's a must for a bunch of different reasons, but I felt like your presentation was a little bit like, are we trying to reinvent another link state protocol when we already have some? And how complex do we want to go with that? And how efficient are we going to be able to implement that? Those are my questions for your work. Thank you.
An observation. Being at LSR earlier this week, 70% of presentation were on optimizing SS for data center, flooding reduction and such. Here we are not even considering SS, so if it's something LSR chairs don't know, or where's the disconnect? You see one working group working on specifically adapting existing IGP to the data center. Here we are saying it doesn't exist. So it's kind of very wide difference. So maybe some further.
Albert Running. So it actually surprises me that you asked me that question, because you are the chair of the other working group working on another data center protocol. So maybe there is a disconnect between you and AC, who are next to each other. No need for liveness protocols or anything like that there. So as you all maybe remember, last year we had this BOF where we talked about, do we need more things? And are there people willing to work on new things? We have, I don't know, 100 people here that showed up that I think says people are willing to work on new things. Okay, 99 persons, 99 people are, I'm just assuming, correct? No, I agree. What I was going to say is that not only do we have people here, there's, I was just looking at the list, my email is open right there. I do see very little traffic on the list, for example. But, to your question, we had the BOF, people said they were interested in working on things. Now I keep insisting, and I said this earlier, that we want focus in the working group to finish the work. One of the conditions that I told the chairs and I told you and Jeffrey was that we were going to charter this for a year and see what we got out of that year, based not just on the people who show up, the people on the list, all this stuff, so that we can actually do the work. In other words, I don't want to be sitting here 10 years from now still talking about whether we do Bgp Spf or not. If we are here 10 years from now, we're probably going to be doing, I don't know, multi-level, whatever the heck it is. But that's the answer, right? We're here because, the community said we wanted to do this. If we don't want to do this, we'll soon lose interest, and that's it. This will die, or either both efforts, one effort, whatever it is. So we'll see where that goes.
So Victor Coursing, chair hat off, operator question was asked earlier. So from a security perspective, my operator hat on is a wide variety of how operators handle security in their data centers, as far as I've seen. Ones I've worked on in different places, people I know who built their things. I think we should probably have it at least extensible and be able to include it. How it's going to be used will likely differ between a lot of operators. So a lot of them have built up walls because they had to from earlier days of how things worked. So I think polling the operators is probably a good idea. To you can at least get a gauge of where the various respondents would likely be, and that might help Alvaro when we talked. If things go up to the ISG and it may not be included day one, but it's something that's expensible, so that such that this is the reasoning why. 50% of operators who hopefully there's a good number of operators that comment. 50% might, I don't know if that's the number, but said we want this or we want that. So that's a comment on that one. And then the second comment, which was the last. Again, chair hat off, still off on the on the last point. I mean, I think a lot of operators have gone to a model, and they all make different decisions. So I can't even think of two networks I've worked on where they've looked the same from how I've constructed them, or the folks I've worked with and how I construct them. We've had network, and some of them like more mobile network, wireline networks, cable co networks. Sometimes it was, ISS with some, VPNs running above it, others where we chose OSPF. There were so many reasons why we made decisions as to what protocols we ran. I think the thing that drove a lot of operators to the world of LSVR and or Rift or looking at this was we're already looking for strong simplifications of what we're trying to do. We're trying, some of them, not everyone's making a decision, is how do I create a simplistic way of trying to deal with large fabrics? So, personal opinion is some might choose, method like this in so much that it allows them to create a minimalist type of deployment, right? Where you don't want to run multiple protocols. You want to run one. You need to, and the other things that come with that are you need to tool this thing. You need to troubleshoot these things. You need to hire people who can configure it, who can, like I said, build telemetry around understanding what's going on. And so I think a lot of those things drive that desire for simplicity. And so I think that's what drives it. So some might very well probably say, you know what, a lot of the changes in OSPF ISS are probably just fine for what we do. You might have a lot of others who make different decisions. Just like I think we discussed this at the BOF, which was, why do we have ISS and OSPF if extensively they almost do the same thing? The answer is there's some subtle differences. There's some advantages and disadvantages. Some of it's religion. And all those things go into what people choose.
Anybody did not? Is it like anybody out there didn't sign the blue sheets yet?
Hi, Ketan Talaulikar, Cisco. Okay, so we talk about the neighbor discovery in BGP. So to clarify, this work or this problem statement came from data centers that are today already using BGP as a hop-by-hop protocol. That's RFC 7938. So this is, in that sense, this is not exactly LSVR, but there is a lot of applicability, and it can be leveraged. And I'm here to share this. This is also going to be presented at IDR, but sharing this for the review, amongst the different options that we have. So BGP, once we start looking at using BGP as a hop-by-hop routing protocol, it was really just a small step from there to look at Can the protocol be extended to make it easier to do the neighbor discovery and the bootstrapping or the bring up of the sessions, just to make that part easier and automatic. There are already data centers where this is all set up and it's scripted, or it is done with different playbooks. But this is about looking at solving this in the protocol in a bit of automatic and dynamic manner. And there are designs where there are multiple ECMP links, or there are only unnumbered, or IPv6 specifically, only link local addresses that are used on the links. And desire to actually do the BGP peerings, even though hop by hop, using the loopbacks is very attractive. But we still do want to use the underlying links for ECMP. So this is the goal. It's specific to BGP. It is not a general, general protocol or extension in that sense. I would also like to say that this is not a link discovery protocol or a link discovery mechanism. It is really bringing element of neighbor discovery in BGP on very close lines of how it's been done in OSPF, ISIS, or LDP for that matter. So the proposal brings up UDP because it's BGP, there is IP everywhere. We want to work on top of IP. So it's UDP based hello messages on a per link basis and only to directly connected neighbors. So the scope is not general BGP, but it is only hop by hop BGP. We want to do the signaling or exchange of peering address and AS number. It's really, we want to take this to a point where this automated discovery takes us to a state where as if a neighbor is provisioned in BGP. So you just say the peering address, AS, and other policies are perhaps part of a template or something like that. So it just does that part in the BGP protocol. We'll talk about peering route setup, and this is because when we do with loopbacks, we do need some automation to get that reachability over the actual underlying links, which, as we discussed, maybe unnumbered or link local addresses. Apart from this part, there is really no change proposed in the BGP protocol itself. It still works the way it does today. There is really minimal changes in the BGP FSM, and based on feedback and comments, we've added more text and clarity in the document. May not really go into all those details, but just to clarify the relationship. So this is the message format, and it's different because BGP has been on TCP, so it's a different message. Port 179, we like that, so we just pick that up, and this is only kept at a linked local multicast address. So it's pretty much similar to OSPF hellos in that sense. This hello discovery can be used over either IPv4 or IPv6 addresses, but in an environment where we have dual stack, expect only one of them to be used. It's not necessary to do it at in both the address families. It's really the AS number and identifier which identifies the BGP router. There is a capability to do liveness here, so there is an adjacency hold time, and then to make it extensible, and we will see some of them, we have scope for TLVs in there. So what are the important or critical TLVs here? So one is the peering address TLV. it can be used to indicate one or more IPv4 or v6 peering addresses that a local router has or would accept BGP sessions on. Optionally, can also indicate which AFIs are enabled for which addresses. This is to take care of, like, for example, dual stack scenarios or other deployment designs where different peering addresses may be used for different AFIs. Then there is a link attributes TLV, and what this does is actually indicate the link addresses, the local link addresses and identifiers. At this point, it defines the endpoint, and this is important because the link. So we are doing hop by hop. It's a topology. There is a desire and requirement to be able to export the actual link topology in a BGP data center via BGP-LS. And these identifiers allow us to do that or describe links and also describe the links in a very accurate manner. It can be used for doing some things like subnet checking or other policy checking before the actual session setup is done. So before the adjacency is accepted, this can be used for checking for any misconfigurations or wrong connections, things like that. At this point, that's what it is. It could be more things could be added based on real operational feedback on what's really required. Then we have the neighbor TLV, and the idea here was to not just discover the peering session and just start the TCP connection to it for the BGP level, but actually have some way that both the sides have agreed and are going to connect to each other. The idea is only really to ensure that we kick or start the BGP peer FSM when we know that both guys are going to connect. When we look at scale and other things, it may not be a good thing just to have sessions, scale sessions, just saying that if one side is not going to connect for any reason. So we'll go over more of this. Then there are certain optional TLVs, and for the peering route setup, we discussed a lot amongst author, and we have put a specific local prefix TLV, and this is really explicit TLV which indicates to the peer that to reach me, my peering address, program this route. So it's explicit in that sense, it's not implicit. And this is required when doing peering using loopback. But this mechanism does not preclude continuing to use the interface addresses for peering, in which case this is not needed. No route needs to be programmed. There is an accepted AS numbers list, and this is again optional, but it is a kind of like a policy check or like a config profile check to ensure that wrong connections may not be done or something like that. It's more of a policy thing there. And then based on the feedback, there is the cryptographic authentication TLV that's been added. It's very similar to the proposal in LDP world for doing security for the UDP neighbor discovery messages there. So this is a brief description of the adjacency state machine. It's called adjacency state machine. Hello. There is an initial state when a neighbor is detected, or a hello from a neighbor is received first. You'll see it's very similar to OSPF in that sense. There is a one-way state when the router has accepted, and it would then include the neighbor in its own hello using the neighbor TLV. Or for some reason we could we are not accepting that neighbor, it's rejected, and then the neighbor would still be there, but it would in the hello, but it would be stated that it is rejected. So the point here is that when the neighbor is rejected, then we do not need to set up a TCP session for it. I mean, neither side would do that.
Finish the slide.
Yeah,
I'll wait.
Okay. Then there is a two-way state, which basically means that both ends have actually, accepted or agreed each other, and this is the point where the TCP session can be initiated on both the sides. This is also the steps where the peering route would get installed in the forwarding by both the routers when doing peering using loopback. And from this point onwards, really the state is created for the BGP peer FSM to take over. It's exactly, at this point, it's exactly as if an operator would have configured the BGP neighbor command, for example, on each of the routers. And once the TCP session is up, then the state is actually updated to establish, and this is really where this thing is. Yes. Yeah.
I want to make sure you're finished with the description.
Yeah.
Okay.
Yeah.
Okay. I'm trying to be very, okay. So I understand your sequence that you're going through. I've actually, but this really doesn't interact in the way you think it does with the BGP FISM. And I'll just stop with that and we can take it offline. It's the BGP FISM is much more complicated than you think. I realize I've been pinged on because I added that stuff to the BGP 40, the latest draft of BGP. Perhaps we should just take this part offline.
Yeah. Okay. So there's some things coming further, but yeah, sure, definitely. I would.
If you start with this as your beginning, you've already made the left turn. So let's just agree to talk offline.
Sure,
okay.
Definitely. Okay. So on the session management itself, and this is the BGP session management. Once the discovery is done and adjacency is set up, done, and the session is done, then the session management is performed as per the BGP FSM. The liveness detection is via the keep alives and the hold timer that we already have. So BFD can be used, fast external failover can be used as well. But if the TCP session is over between the loopbacks, then this mechanism can be used to actually do the BFD or the fast external failover over the underlying links. Okay, so there is a subtle difference, but those mechanisms are still there. A BGP session which is established is not brought down due to the hello adjacency hold timer by default. So this is a mode which is a default mode where the liveness is left to the BGP FSM keep alives and all of that. Now, optionally, we've got some feedback. Certain operators may want to really use the hellos as a faster liveness mechanism, and they may not want to or able to use BFD or other mechanisms. So in those cases, actually the hello can work for liveness, and it would be very similar to how BFD brings down a BGP session, right? But that's an optional mode. One key thing is that when the BGP PRFSM or when the BGP PRFSM is down, or it's not established basically, and we lose a adjacency. In that case, we do want the peer state to be cleaned up in BGP. So that's really one key interaction there. And this is because these are auto-discovered BGP sessions, and no matter what mechanism, how we set them up, we do want them to be cleaned up when that adjacency goes away. And that this is just that part. The peering route itself is really for when the peering is done using loopback interfaces. Now, this route does need to be programmed with a higher admin distance than the normal BGP routes. And this is because this is the reachability over which the BGP session has been established in the first place. So it is possible, maybe not by design, or it is possible that the same network or same prefix is also learned over BGP itself. Now, we don't want to end up in an oscillation scenario where that replaces the BGP route, and if somebody withdraws it, the BGP session itself goes down. So we do need this in the FIB. So this is done by the adjacency, let's say adjacency mechanism in here. Now, when there are multiple links between neighbors, then the peering routes will have multiple paths, one for each adjacency or each link between them. And this is how it is discovered. Similar to how it's there today, there's no change, but the BGP next hop for the neighbor would actually end up getting resolved over this peering route. So the purpose of this peering TLV is to really do away with the need for some static route or running some other protocol when doing peering between loopback addresses. And obviously it allows the fabric to be unnumbered or using IPv6 link local only. So there is a working group adoption call ongoing for this in the IDR. We welcome feedback inputs. Obviously, operational inputs from operators is very important, but as well any other details that need to be clarified or updated.
Kevir Patel Arcus, I suggest you ask for implementers' feedbacks also, aside from an operational feedback, because some of these mechanisms, even before they hit the network, has a severe scale concerns that are imposed. For instance, inside BGP, keep alive machinery itself has its own scale limitations, and there has been work done over numerous years across multiple implementations to handle this. So bringing something inside BGP like this has scale limitations, which you probably should lay out what they are if you think you have covered them. I think you got the comments on the IDR working group where a lot of us have actually gone ahead and rejected this. The second thing I would say is...
Can I respond? To
let me finish and then you can, right? The second thing I think it is, if you answer to this to say, hey, look, there are scale concerns, but we want to take it out of BGP and do it in a manner that it doesn't impact the core BGP machinery, then you got to specify how the FSM state would work out for this. And if you're going to do it outside BGP, then the right question to ask is, why not try and do it generic? You have UDP port that you've opened up aside from TCP port. Implementations will need to worry about COP policies. What are the repercussions of changing the default COP policies? And what happens if you just keep on dropping hellos? And the keep alive stays. And you proposed in the draft that, oh, by the way, when the session gets established, I'm going to disable the keep alive machinery. Wait, I can make it optional if you like. What am I supposed to implement? I think the authors have to really flesh these things out before even we go to the working group call. So those are my feedback.
Yeah, sure. Thanks. So on the, I'll start in a different order. Why do it? Why not make it generic? Why do it? Yes, it's UDP and we picked port 179. Why do it generic? The reason why it was not made generic is because it was intended to be purpose for purpose built for UDP. There was no desire or requirements, I would say, for it to carry any other protocol or any other thing. That was not the intention. I mean, at least that's not within the authors. So that's where we picked port 179 and we kept it this way. Now on the implementation aspects, yes, can I? Yeah, go ahead.
Okay. Kevin Wang from Juniper. I can understand that the idea is very similar to LDP and label discovery. However, the difference I can see is that LDP, the way you can auto-discover the session because there's nothing specific for the session. But in the BGP case, like every session you could have different address families and a lot of different since you need provisioning. So the way you assume that you can auto-discover, does it mean that in this data center environment, the address families or those parameters are usually same for all of those sessions? Otherwise, you still
yes, there is no such assumption actually. So there is some text in the draft which clarifies it would have to be based on auto discovery is not just by itself. There would have to be templates, or like we have, for example, neighbor group or neighbor set. We would have that template and have an association of that template with a set of interfaces over which this discovery is to be learned. So it's not like everybody is the same, and the policies they can be done on that template basis.
But if you have to configure those templates, how is it different than configuring BGP session today?
Because the templates are really depending on the position in the network in the clause. The templates are really generic for if I'm connecting to let's say it's a leaf, it's connecting to spine 1, 2, 3, 4. It's really the same thing. If it's connecting down, let's say you enable it with at a TOR, then it's similar. There is no, again, we had that discussion earlier. There is no that much policies that we're talking about here in the data center, right? We discussed that earlier in the working group. There were not that many policies. So still you can have different templates and associate them with different interfaces to do that.
Okay, I'm going to put a little finer point on my earlier one because I think it may be helpful and germane. Look, the reason why the BGP state machine in 4271 is so interesting to read is because we actually worked with the implementers and actually took in all these various options and tried to make it so it was bulletproof. What you're moving with doesn't really encompass that information. I realize it's not easy to pull out of the state machine. And so if you're building on something that's not quite solid because you don't have a solid piece, and this is where I'm going to encourage you, like Kara did, is to actually work with the implementers. Why that 4271 was so carefully worded is we worked with all the implementers, and people who've added new implementations have had to interact with those, and that state machine is extremely important. What's happening in this draft does not align with those existing state machines, so it would be very difficult to put inside of BGP as it stands. Now, I believe the authors can refine and work through that, but it's not there. So I would urge you to put a pin in it, pause, make sure you've got that Talk Like Care and other implementers, make sure you actually see what is in there and has been working in others. I'm sure several of your Cisco buds will work with you on that. So I have faith in that you can do this, but you really sort of have to take a pause, get that right, and then come back. This is me in my 4271 editor's hat. You got to go back and rework this. Now that I've listened to your presentation, you got too many misses to really be a forward path the way you have it. Thank you.
Okay, yeah, I agree and accept. So I think the comment is to really go into more details and specifics on the interactions with the FSM. Yes, right, okay. And coming to the keep alive or the scalability aspects, yes, the implementation has to be done in a way that it scales. You're correct in that. And when it's really, we thought it's really an implementation specific aspect of how to do it, whether to I mean, it's obvious that it should be done in a way that it does not affect as a separate thread or maybe even outside the process. I mean, all of those options are implementation options for sure. Yeah.
So, just to close on a few things, Keyur Patel Arcus, without going into and not wanting to go into protocol wars here, I have not seen the kind of neighbor session scale that we see in BGP, whether be it inside an MSDC or across an L3 VPN edge, where this thing could have applicability at numerous points. I've not seen that scale inside IGP. So I suggest first, as you look at the solution and you try to come up with something, take a look at it and say, how do you scale this out? And when you scale it out, at that point, you probably want to consider whether you want to do this within BGP or outside. And once you have that right, then that would be a good point to cover all the semantic information needed to get the solution right, because there are multiple holes in it.
Sure, yeah, thanks.
Okay, thank you. Anybody has the last blue sheets? Like one packet missing somewhere.
Okie dokie. Now's your time to run. You have to listen to me again. This is yet another proposal in the space. I don't intend to go through the internet draft. You're supposed to have read it and remember it from last time. This is mostly what the differences are, but just to give you a light refresher, the idea is down below. Let me find the right buttons here. At as close to the link layer as we can get, exchange of PDUs for link state, then AFI-SAFIs or encapsulations, and John has beaten me up, and everywhere you see AFI-SAFI, think encapsulation, are discovered in the exchange and then pushed up to Bgp Spf that does the topology and routing. Okay. Essentially, the protocol looks like find each other's MACs and IDs and start MAC level keep alives. Okay. Then you can tune the timers for those keep alives and any higher level acts. Then negotiate a capability exchange. What encapsulations does this link support? And then you can announce, exchange the particular encapsulations addresses. So for instance, here's the hello keep alive, right? And it's local ID. And one of the things that's changed, unfortunately, I don't think it's the next slide, is an ID is not an AS, an ID is an AS, or a router ID in the classic sense, or an ISO, IS identifier, whatever you want, right? Okay. Next, you negotiate the encapsulation supported. That negotiation is V4, V6, the Mpls flavors, etc., extensible. Okay. If this is at the ether layer, should the different encapsulations be at separate ether types? Good question, John. So I'm going to take you through one example of an encapsulation exchange because it has this one little guy, which is interesting to the previous discussion, add drop. And is this the primary exchange? And what I meant there isn't very good, but there's room for flags here to say, hey, this is a primary interface, or this is something like an indirect interface, like a loopback. Okay, so you've got the prefix and length, and that for each one. Very boring. Boring is good. So the summary of the changes between the last draft is the node identifier, as I said, anything unique. The MPLS label became a list. There is no more northbound protocol. It's just replaced by using the BGP LS and its extensions API. And then there's some administrative stuff like the IANA considerations and references got filled out. The node identifier can be an ASN, a router ID. Ooh, the 4 has to be in black here. It's the ISO. And anything that's unique in the space, it makes no difference what it is. The point is uniqueness. Okay, the MPLS label list, this is very exciting. There's a count of them and a list of them. Okay, northbound, instead of a protocol, just escape, steal it from Bgp Spf, and just take the Bgp LS TLVs and say, here they are, and the rest is an implementation detail. Okay, if there are multiple addresses on a link, multiple TLVs are pushed northbound having the same ID pair. Okay. A node, similarly to Bgp Spf, the local and remote nodes descriptions are described in Bgp LS segment routing EPE. Okay, just go, Sue, come on.
Could we not do that? Just working group hat chair, please. Either put it in a separate spec where you both go to it. I'll talk about why after line, but maybe I just say that as a reviewer of that particular draft, and here Katana and I have been working through that one, could we just take the node specifications, maybe make another third short draft? That draft is a little difficult in that area. That's just just
don't get me started on BGP LS and its extensions.
Yes, just let's make them separable.
So you have a procedural way you'd like to restructure so as not to invoke as much. I'm certainly negotiable in the space.
Please, thank you.
Okay. Northbound MPLS stuff. Here's another pull from yet another extension to BGP LS and section. Same comment from Sue. Security, this version has no security. Waiting for the basic skeleton to settle. I believe in authentication and integrity. Watch out. This gets the, please.
Wim Hendricks from Nokia. I had a question on the previous slide on MPLS. Why are we putting MPLS inside of this? Because the labels should be part of the routing protocol potentially. I do see a need for the IP address, but why do we put labels inside of this?
Go do it. Go. My co-author.
We can take it out. I know Bruno asked earlier also, but this was put in specifically with server-based applications in mind. If we were to do label-based forwarding all the way up to the servers, this would be a good thing. I think when we looked at the draft that Kiriti had proposed earlier, it looked like a fine extension where he wanted to handle it at an ARP level. We thought while the discovery is happening, you're going to learn something from the server side, might as well pop in a label and be done with it.
Yeah, or yeah, we would extend LSVR up to the server. Or you could.
If your implementation can build graphs all the way up to server, do it.
So it would be optional, actually. Yeah.
Oh, you don't have to. You don't have to. You don't. Back at the capability exchange, you say, well, I don't talk MPLS.
Just as
Who are
the
you?
author of co-author of the two BGPLS drafts, I think we are at a very advanced stage with them and will work to correct them. But I'm not sure we want to remove it from that document for.
Maybe we don't want to go down
We'll
this
take
in
it
this
offline.
context. Okay. Security. As I said, do we have lots of time? We have lots of time because I haven't got many more slides. I work in the NOC here. For years, there has been a magic password that is on too many devices that Rob and I have been screaming about. If you'll notice, you're on the global internet. They dropped 2 Polycoms with those passwords on them on the network. Within 15 minutes, they were owned, and now the credentials are widely known everywhere. The NOC is scrambling to clean up the mess. Because, I mean, you don't want to know how far those passwords had permeated. Let's not do that again. And that's my last slide. I'm under direct orders to have a cat in every presentation.
AC Lindum. So I guess we'll know who we need to find if we need to herd these cats.
Oh, I have a great, you've seen the movie, haven't you? Oh my God, do I have something for you.
So, Himanshu from Siena. I'm not very familiar with this protocol, but I just listening to the conversation for the previous presentation and this proposal, the scalability was noted as a big aspect of the adjacency or the neighbor discovery. Does the scalability issue applies here or no?
It's specifically trying not to. I have a presentation I did a month or two ago at RIPE, which is the basic problem being attacked in this whole space is the fact that IGPs are noisy. They're very noisy. And their noise is not linearly proportional to the number of nodes. Unfortunately, it's superlinear. And so much so that a very respected member of this community, Tony Lee, is madly working on trying to partition the IGP noise space to see if IGPs can scale to this. And by IGPs, we mean ISIS and OSPF, of course. Here, the idea is this just has the noise scaling of a single link in a data center, okay? And the changes are infrequent. And BGP, which is a very quiet protocol, only propagates changes.
No, I
is what's
follow.
global.
I follow what you are saying, but I don't think that is applicable because I think the only the neighbor discovery part was detached from the IGP protocol to discover the neighbor for BGP, because the BGP doesn't have an auto discovery for the neighbor. User has to configure the IP address, and we want to get over that hump. So, okay, there is various schemes. That neighbor discovery part of the scheme is what we are talking about, not the whole IGP. I mean, yes, there is a whole IGP related activity that is happening for reducing the flooding and all that. So that's all parallel activity for data center in IGPs at IGP level, and then there is this group here, there is overlapping and all that. But I'm not talking about all that. I'm just talking about there is how does BGP auto discover a neighbor? And you have a proposal, there was another proposal that does a part of the IGP, not the whole IGP, just the neighbor discovery part. And the scale was noted as a big issue with that. Again, it is outside of
propagated
BGP.
through BGP.
Hmm?
That's because that.
It's outside of BGP, yes.
No, it
needs to be
wasn't
stitched.
outside of BGP in the previous presentation.
No, it's a neighbor. Okay, if you look at it from an isolated way, or step back and say, okay, I need to discover the neighbor. We discover the neighbor for BGP in this specific issue. It is outside of BGP state machine and all that stuff. But then once the neighbor is discovered, you hand it off to BGP and let BGP do whatever it's doing, right? So there is no interference between the two once you have done your part, the discovery part, and then hand it off to BGP. No, I have not read. So I don't. No, okay. Let's say if we remove the interaction part and you look at it from the isolation from just the neighbor discovery, then would it work?
So look, as I understand, and I'm not Keyur Patel Arcus, without trying to get into a protocol war, the hello machinery inside IGPs not just do a neighbor discovery, but it does a lot more. We have part of that machinery already taken care of inside BGP using Keep Alives. Keep Alives, if you look at BGP scaling issues, there are of many, the two big scaling issues are route scale, path scale, and peering scale. The peering scale has a direct correlations with Keep Alive, specifically when you go to 8,000, 16,000 neighbors where the applicability could be there, right? Not in data centers. Now, then the normal option is, do I take it within BGP or do I take it outside BGP and create a database? And that is where I think hopefully the answer to your question comes around.
I still want to say that it's a phase one. You do the neighbor discovery, you find the neighbor and just hand it off to BGP, not to affect any of the BGP keep alive or anything like that. It is just to overcome the requirement that user has to configure the BGP peer. We want to auto discover the peer. Here is the scheme. You found a neighbor. You now carry on as how you would do it.
Exactly what this is attempting to do.
Right.
I suggest you take that criteria and look at the other
Right.
drafts.
That's why I'm comparing apple to apple, not an apple to orange. We don't want to have those stitches between after the discovery with the BGP keep alive or anything like that. You just have discover the
I
neighbor.
don't think anybody's disagreeing with you.
Your ask is valid.
Okay, all right.
One other thing I wish to confess is I'm hoping after some more study of Rift that this may be reasonably extended or modified to also deal with their discovery issues. AC?
AC Linda, Rift has its own discovery.
I understand.
Okay, but you might, yeah, this would help bootstrap it. Okay.
Okay, thank you. So I think we're done then for today. Thank you.
And I specifically not asking for adoption.
Yeah. So sorry, I missed your comment as chair of Rift. We've got the protocol and working group. It has full auto discovery machinery built in. It needs none of this.
Okay, thank you. We're closed.
Yeah, thanks.
Over in the big building. I saw him in. Over in the park. So I'll go rough these off since I'm going to go on. Hey, how's your capability to run?
I did some calculations.